All right, so let's figure out how to do this one right here. So usually when I look at a problem like this, I see a function within a function, and I think, okay, substitution, chain rule from the derivative. So my first guess on this one would be to let u equal 3 sine of theta. If I do that, then du would be 3 cosine of theta d theta. And I don't have an extra 3 out there, so I'll divide the 3 over and say that's 1/3 du equals cosine theta d theta. All right, so let's see. I don't have a cosine, I have a cotangent. Well, when we were playing around in Calc 1, I said, well, sometimes it's good to rewrite things like cotangent as sines and cosines. So I'm going to try that here. Tangent is sine over cosine, so cotangent is cosine over sine. So this would be cosine over the sine times the natural log of 3 sine theta, theta, parentheses. So now what's looking good? Well, the u is my 3 sine theta here, so I've got a u right there, so that's good. And then the cosine theta d theta, I now have that, but I've got this extra sign hanging out there that I'm going to have to contend with. So let's see if that's going to work. So I'm going to just start the substitution and see what happens. So this should be the integral of, I'm going to put the natural log of u in there. Cosine d theta is 1/3 du. I'm going to put the 1/3 out front in the du here. So this is gone, that's gone, that's gone, but I still have the 1/sine here to deal with. So up here, I could say, dividing by 3, 1/3 u is the sine. So then this would be 1/3 the integral of 1/1/3 u natural log of u. Am I much better off than I was before? Well, the 1/3s are gone, so this is now could be written as the integral of the natural log of u over u du. And that's a problem. So 2 choices. I could try to do another substitution on this u thing by using a v, or I could scrap this and try a different substitution. That's what I'm going to do. So it didn't, well, I mean, here's the thing. How do you know what the right substitution is? You don't. You just got to try. So that didn't work. So next, I think I'm going to go for this whole thing there. The natural log 3 sine as my u, because this one didn't seem to work. I ended up a situation that's not too much better than what I started with. So trying again, now I'm going to try u equals the natural log of 3 sine theta. So then my du, let's see, derivative of the natural log is 1 over whatever was inside. What was inside was 3 sine theta. And then the chain rule says I got to multiply by the derivative of what was inside. Derivative of 3 sine is 3 cosine. And let's not forget the d theta. The 3's cancel. Sine or cosine over sine is cotangent. Holy crap. This looks like it's going to work because I do have a cotangent d theta right there. Okay, so this happens often to me. I think I know what the substitution is. I try it and stuff goes to hell. That wasn't too bad, but all right. So now I have a substitution that's going to work. So here is now my u, and the cotangent combined with the d theta is my du. So this integral becomes the integral of u du. Right? U is the natural log, and du is cotangent d theta. The antiderivative here would be u squared over 2 plus c. And translating it back, u is really the natural log, so I would write it as the natural log in parentheses of 3 sine theta, close parentheses, close parentheses, close parentheses, square it, all over 2 plus c. So sometimes it takes more than one try to figure out what your u is ought to be. So don't be afraid to try and try again.